how to solve the equations when there are variables as well as numbers in the denominator. In the previous module we saw how to solve the equations when there are variables in the denominator. We substitute, right? We substitute the common denominator. Now in the next sum we will see along with the variables there are numbers in the denominator. Let's see what to do. Let's take up a sum. Exercise 3.6, sum number 1, sub question 1. The sum is 1 upon 2x plus 1 upon 3y is equal to 2. 1 upon 3x plus 1 upon 2y is equal to 13 upon 6. So how is this sum different from the previous sums? As I said, in this sum there are variables as well as numbers in the denominator. Now to get rid of the variables we substitute. Now question is how to get rid of the numbers from the denominator. Look at it separately. Variables we will remove it later by substituting. First let us remove the numbers from the denominator. Now the question is how to remove the numbers 2 and 3, 3, 2, 6 from the denominator. Obviously you already know it, we need to multiply throughout by the LCM. Right? So to get rid of the variables we substitute, to get rid of the numbers we multiply throughout by the LCM. Chalo. Let's take the first. The denominators are 2 and 3. So to remove 2 and 3 we'll have to multiply by the LCM of 2 and 3. What is the LCM of 2 and 3? The LCM is 6. So let's multiply throughout by 6. Now when you multiply throughout by 6, multiply every term by 6, what happens? 2 3s are 6, 3 2s are 6. What remains? 3 into 1 upon x. What is 3 into 1 upon x? It is 3 upon x. 2 into 1 upon y is 2 upon y is equal to 12. Now this equation looks something similar to what we have already done, right? Variables in the denominator module. Let this be equation number 1. Let's take the other equation. What is there in the denominator? 3, 2 and 6. To remove 2, 3 and 6 from the denominator, we'll have to multiply by the LCM and the LCM is 6. So let's multiply throughout by 6. What do we get? 3 2s are 6, 2 3s are 6, 6 1s are 6. So what remains? 2 upon x plus 3 upon y is equal to 13. Let this be equation number 2. So after multiplying throughout by the LCM, we got the first and the second equation. Now look at both the equations 1 and 2, something similar to what we have done, right? Are these equations linear? How to make these equations linear now? By substituting, something similar. Now everything else is similar to what we have done. This was the only different part in this particular sum, right? Chalo, let's revise. What we should substitute? We should substitute the common term or the common denominator in both the equations. It's very clear the common denominator is x and the common denominator is y. So we should substitute 1 upon x as p and 1 upon y as q in the first and the second equation. Here you will have to specify 1 and 2 because we have numbered them specifically, right? Chalo, let's substitute in the first equation. What do we get? 3 upon x will become 3p, 2 upon y will become 2q is equal to 12. Let this be equation number 3. Let's substitute in the second equation. What do we get? 2p plus 3q is equal to 13. Let this be equation number 4. Now let us solve these equations by the method of substitution. What do we do in substitution? We number the equations first, which is already done there. Then we consider one of the two equations. Which one to be considered? Whichever equation is simple. You can consider either of the two equations, right? Let's consider equation number 3. Let's do it. What do we get? We shift one of the variables to the other side so that we get it either in the form of p is equal to something or we get it in the form of q is equal to something. Chalo, let's shift q to the other side. What do we get? We get p is equal to 12 minus 2q and this 3 comes to the denominator, to 12 minus 2q upon 3. Now many students looking at 12 in the numerator, 3 in the denominator get excited and tend to cancel. 3 4s are 12. Never do that mistake because there is a minus sign. It is 12 minus 2q. It's one term, right? So you can't cancel 3 and 12. Remember this. Don't do this silly mistake in the exam, right? Chalo. Number this equation as equation number 5. Not 3 this time because 1, 2, 3, 4, 5, right? Now what do we do? The name of the method is substituting. Substituting something. Substitute what? We need to substitute equation number 5. Where we need to substitute? The equation which was not considered. Which equation was not considered? Equation number 4 was not considered. So let us substitute equation number 5 in equation number 4. So in equation number 4, in the place of P, you will substitute equation 5. That is 12 minus 2q upon 3. Let's do the substitution. What do we get? Look at equation 4. Instead of P, substitute 12 minus 2q upon 3. So what do we get? 2 bracket 12 minus 2q upon 3 plus 3q is equal to 13. Now what do we do? Will that 2 and 3 get cancelled? No. Previous sum it got cancelled because it was divisible. Now here we will have to open the brackets, but 2 will get multiplied only to the numerator, not to the denominator. Chalo, let's multiply. 2 will get multiplied with 12 and 2 will also get multiplied with minus 2q. Let's do it. What do we get? 2 12s are 24 minus 2 2s are 4 upon 3 plus 3q is equal to 13. Now we want to get rid of that 3 from the denominator. So what should we do? LCM. First we will multiply with 3q. So what do we get? 24 minus 4q plus 3 into 3q will be 9q. The whole upon 3, don't forget this, is equal to 13. Still we have 3 in the denominator, so what should we do? Cross multiply. We get 24 minus 4q plus 9q is equal to 13 3s are 39. And finally, we get rid of 3 from the denominator. Now, variables on one side, constants on the other side, solve and get the value of q. Let's do it. 24 minus 4 plus 9 is plus 5, so it's 24 plus 5q is equal to 39. Shift 24 to the other side, we get 5q is equal to 39 minus 24, which is 15. So we get q is equal to 15 upon 5, which is 3. Now substitute this q is equal to 3 in equation number 5. In equation 5, let's substitute q is equal to 3. Why are we doing this? To find the value of p, right? Let's do it. We get p is equal to 12 minus 2 into 3 upon 3. 2 3s are 6. 12 minus 6 is 6. 6 upon 3 is 2. I hope this calculation is clear. Something which we have done many times. So we have just done it directly here. We just did it directly here, right? So 12 minus 6 upon 3, that's 6 upon 3, which is 2. We got p, we got q. Is the sum over? No. Why? Because we are interested in x and y. Can we find x and y now? How? By resubstituting. What do we resubstitute? We resubstitute p is equal to 1 upon x. What's the value of p? 2. So we get 2 is equal to 1 upon x. Cross multiply, you get x is equal to 1 upon 2. What is the other resubstitution that we do? We resubstitute q is equal to 1 upon y. What is q that we got? We got q as 3. So we got 3 is equal to 1 upon y. Cross multiply, you get y is equal to 1 upon 3. So x is equal to 1 upon 2 and y is equal to 1 upon 3 is the solution of the given simultaneous equations.